From a research perspective, there are many things that are going on in the area of socio-technical systems. There are individual research groups here at MIT and other universities who are trying to observe and understand these types of systems, to model them, and see if they can contribute to the body of knowledge of how we need to architect and evolve these types of systems. Industry is in the thick of operating such systems, in the thick of having to make changes to these systems. And so academia can then come in and provide a means for them to kind of observe what's going on and to look for patterns and things that they themselves may be too close to observe. In an academic setting, we can work on general frameworks and strategies that others can use to apply to the architecting of socio-technical systems. So engineering is inherently a model-based discipline. We've always developed models when we perform any kind of engineering, but now the power that we have from a computational perspective and the needs that we have as far as the interconnectivity that's needed are really driving us to a higher use, a more powerful use of models. An emerging area is what's been labeled as digital twin. Digital twin, some people would say, is just a model that's kind of an exact copy of an actual product or system. With the existence of a digital twin, the models receive sensor data from the actual operational system. And then those sensors are used to gather real-time information about the environment, about the operations of the actual system, and to contribute that back to the model. So the model will be helpful to you both for analysis of how well your system is performing, but also to allow some level of predictability, say, in terms of the end of life of a particular aspect of your technology. So an example of a digital twin is the work that GE's been doing with wind farms. For every wind turbine, there's a model. Every wind turbine has sensors on it to collect data and send it back to the model. With this kind of approach, you can look at the differences, say, in the wear and tear on an individual turbine. You can start to predict when end of life or replacement of parts might be possible. And you can also, with this collection of models, this collection of digital twins, you can start to look at the performance of the whole digital wind farm itself. Digital twins in their full realization are far and few between right now. In the future, there's going to be kind of an inversion of the intellectual property. That today, for example, your hardware component might be your valuable piece of IP, but in the future, it's the model itself that's going to be possessing not only the same characteristics that you would have in your hardware, but it's going to be armed with historical information of its performance. It's going to have the capacity to project out into the future.